Good afternoon, teachers. This is again another video discussion, which is part 2 of the video discussion of the derivative. So in the previous video, we discussed about 3 formulas. No? So this time we are going to use the general formula or the formula number 1 based on the definition here taken from Tisiwag, the calculus with analytic geometry by Lighthold. The derivative of the function f is that function denoted by f such that its value at a number x in the domain of f is given by f prime of x equals the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0 if this limit exists. So we are going to use this formula all throughout in our examples. Example number 1. Find dy dx if y is equal to the square root of x minus 5. So dy dx, okay, it's not pronounced as dy over dx. So in the solution, again, we are given y equals the square root of x minus 5. So dy dx is equal to the limit of, from the formula, f of x plus delta x minus f of x all over delta x as delta x approaches 0. So by substitution, okay, this is the function, square root of x minus 5. We replace x by x plus delta x. Okay, so you have x plus delta x minus 5 minus your function, okay, which is square root of x minus 5. All over delta x as delta x approaches 0. Now, in order to evaluate this limit, we shall rationalize. Okay, so how do we rationalize? We are going to multiply this fraction by the conjugate of the numerator. So this is minus, so this must be plus, okay, with the same radicals. Okay, so the purpose of this is to eliminate the radical sign in the numerator if possible, and this is based upon the special products x plus y times x minus y equals x squared minus y squared, okay, which is first to first term, second to second, okay, and then squared. Squared because we know that the square of a radical is equal to the radicand, alright, meaning if we multiply a radical by itself, say square root of 3 times square root of 3, the result is the radicand, okay? Because square root of 3 times square root of 3 is equal to square root of 9, which is 3. Okay, so what we're going to do now is multiply first to first radical, then second to second radical. So again, because of this concept, we can eliminate the radicals there. So that we have in the numerator, x plus delta x minus 5 minus x minus 5. So take note, we enclose that with a parenthesis because of the negative sign here, okay? Take note that it may affect the signs of the enclosed terms, so you have to see to it, especially if you have a binomial, trinomial, polynomial, no? It may change the signs of the enclosed terms. Okay, and then just multiply delta x by square root of x plus delta x minus 5 plus square root of x minus 5. Okay, so we can do cancellation now because we can cancel x minus x and negative 5 plus 5. The result of negative times negative 5. So, the leftover in the numerator is delta x, which can be cancelled with the delta x in the denominator. So, the leftover is the limit of 1 all over the square root of x plus delta x minus 5 plus square root of x minus 5 as delta x approaches 0. So, when we evaluate the limit, our delta x is equal to 0 so that we can see two the same radicals. 1 over square root of x minus 5 plus square root of x minus 5. That is why we have the derivative 1 over 2 times square root of x minus 5 as our answer. Then let's proceed to example number 2. Find d dx of 5 minus x all over 3 minus x. So you have d dx. Okay, so in the solution, d dx of 5 minus x all over 3 minus x Okay, so we're going to substitute again this one, no, to our formula number 1. And then we replace this with the same format, no? We replace x by x plus delta x. Okay? For the first fraction. So we have 5 minus x plus delta x. Again, it's being enclosed because it's preceded by a negative sign. Alright, then 3 plus x plus delta x minus the original function. 5 minus x all over 3 plus x. All over delta x as delta x approaches 0. Alright, so let's eliminate the grouping symbol here. So you have 5 minus x minus delta x and copy the rest. So you have 3 plus x plus delta x minus 5 minus x all over 3 plus x all over delta x as delta x approaches 0. Okay, now if you recall in your algebra, so we can multiply, no? We can multiply the complex fraction here by the LCD of the denominators of the grand numerator. So this is our grand numerator and this is our grand denominator. So that our grand numerator will have only one fraction, we are going to multiply this both, no? The grand numerator and the grand denominator by the LCD. So cancel. So that the leftover is 3 plus x multiplied by the numerator, 5 minus x minus delta x. And then cancel this. So that the leftover is 3 plus x plus delta x times the numerator, 5 minus x. So again, this is negative taken from here. Okay, then delta x multiplied by 3 plus x plus delta x and 3 plus x. So you have here the denominator, delta x times 3 plus x plus delta x times 3 plus x as delta x approaches 0. Now, in the next step, you see that I made some cancellations, okay? This is because 3 times 5 is equal to 15. 3 times negative x is equal to negative 3x, and so on and so forth. So that's algebra. So after cancellation, you have a leftover of positive 5 delta x minus 3 delta x. So the result there is going to be 2 delta x. And again, delta x here can be cancelled with the delta x in the denominator, so that our leftover is the limit of 2 all over 3 plus x plus delta x times 3 plus x as delta x approaches 0. So when we evaluate this limit, our delta x is equal to 0, so that we can see that our denominator contains the same binomials, 3 plus x and 3 plus x. So you have 2 over the square of the quantity 3 plus x as your final answer, which is the derivative of the given function, f of x equals 5 minus x all over 3 plus x. Okay? So, thank you very much. That's the end of our discussion for today. This is Dr. Batukan saying mathematics is easy to learn when one learns with enthusiasm. Bye!